right, hello everyone. We're going to continue our probability unit, and today we're going to look at something called conditional probability. So first, let's look at our do now. It says if x minus 1 is a factor of x cubed minus kx squared plus 2x, what is the value of k? Now, this was a very old topic that we've done, but whenever the question is talking about a factor, you're looking for the remainder theorem. So, remainder theorem. Okay? So, for the remainder theorem, your first step was to take your binomial, so x minus 1, and set it equal to 0. So then we solve. We add 1 on both sides, and we get x equals 1. So that was step 1. The second step was to take this value and plug it in for all the x's in the other polynomial. So I'm just going to write it out first. X cubed minus kx squared plus 2x. Now we're going to plug in 1 for x. So here's an x, so we plug in 1 cubed minus k times 1 squared plus 2 times 1. I know there's a k there, let's not worry about that yet. Now there was one more important thing of the remainder theorem. When you have a factor, so when you have a factor, the remainder is 0. Okay? So, what we would have done if this was a regular remainder theorem problem is type this into the calculator and get our remainder. But we already know it. Because x minus 1 is a factor, this is equal to 0. And now we just have to solve for for k. So we have 1 cubed, which is 1. Then we have minus 1 squared is 1, so this just stays as k. 2 times 1 is 2, equal to 0. Combine like terms, 1 plus 2 is 3. So we have 3 minus k equals 0. We're solving for k, so we have to get rid of this 3. So we subtract 3 on both sides. We get negative k equals negative 3. K is not by itself yet because it has that imaginary 1 in front. So we have to divide both sides by that negative 1. And then we get k equals 3. Okay? And so our answer is answer choice 3. All right, so this is just kind of a review of the remainder theorem. Now let's get into some probability. So it says draw a tree diagram to represent the following situation and then answer the questions. A family has 2 children. Assuming that boys and girls are equally likely, determine the probability that the family has. So before we're going to answer these, we're going to draw a tree diagram. Again, we are going to assume that the only 2 options are boys and girls for this problem. So we're going to have child 1. Now child 1 can either be a boy or a girl. So B or G. Now we're going to figure out child 2. So if child 1 is a boy, the second child can either be a boy or a girl. If child 1 is a girl, the second child is either a boy or a girl. And this is now our tree diagram. So let's answer the questions. So part A says, what is the probability that the family has 2 girls? So if we look at our tree diagram, this represents a boy and a boy and a girl and a boy, a girl and a girl. Of all those answer choices, there's only one possibility that there's going to be 2 girls out of the 4 total possibilities. Because remember, we can either have a boy, 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 girl, girl, boy, girl, girl. So let's look at part B. What is the probability that the family has 2 girls if you know at least one of the children is a girl? So now, in this case, we are not looking at the option of 2 boys. I'm sorry, that looks a little confusing. We are not looking at the option if there are 2 boys. So this branch here doesn't matter to us because at least one of the children has to be a girl. So now, probability that there's 2 girls. We now have boy and a girl and a boy, a girl and a girl. So we have 3 total outcomes and only 1 out of the 3 was there 2 girls. Now let's look at the last part. It says, what is the probability that the family has 2 girls given the older child is a girl? So now, child 1 has to be a girl. We are not looking at this branch at all. So now, looking at this, you can either have a girl and a boy or a girl and a girl. Those are your only 2 options. So the probability that there are 2 girls is 1 out of 2. Okay? Notice what we did in this problem is the total outcomes, so the denominator, was limiting each time because of the restrictions that the problem gave us. In this one, it said that at least 1 had to be a girl, and in part C, it said given the older child is a girl. So they were limiting our total outcomes. So that is what we're going to be looking at today, and that is what conditional probability is. Conditional probability is the probability of event B occurring given event A already happened. Okay, so it's based on a condition. The key word for today is going to be given or something along those lines, such as if we know or anything else like that. Okay, so in conditional probability, we're reducing the sample space, as you saw in that first example. The given, so the condition, is always going to be in the denominator because that represents the reduced space. You're going to see what that means when we get to some examples. Okay, so first thing we are going to do is we are going to take some probabilities from a table, okay? We haven't done this yet, so let's take a look. All right, so part A says the probability of someone going to college. I just want to talk about this for a second. So in this table, there's 2 things going on. We have a male and female, and we have going to college and not going to college. We also have the totals of each. So this total here would be 16 plus 13. That's how we got that 29, okay? Now you see that there's also totals down here. That's when you're adding vertically. So this is 16 plus 14. That's how we get 30. This total in the corner is your total overall. It's adding all of the totals together. So this is your absolute total. So let's look at our table now. So it's saying, what is the probability of someone going to college? They did not mention male or female, so we are only looking at going to college. Okay, again, we don't care if it's male or female, we want the total. So the total of people going to college is 29, and the total number of people surveyed is 52, the absolute total. So that is the probability of going to college from this table. Okay, let's look at the next one. It's saying the probability of not going to college. So again, we're not looking at male or female, we're only looking at not going to college. We're not looking at male, not looking at female, we're looking at the total. So the probability of those not going to college, 23 out of the total 52 are not going to college. Okay, let's continue on. I'm going to keep this circled because that's our absolute total. Now we have, what is the probability that we have a male and going to college? So now we are going to use these male-female columns. So we care about going to college, right? We don't care about not going to college. And we care about the male number. So here's the male number. Here is going to college. They intersect at this point right here. Going to college and male. So that means that 16 out of the total 52 people surveyed are male and going to college. Continuing on, we're looking at now female and not going to college. So we're looking at not going to college. We're not looking at the male column, we're looking at the female column. If we look at where those two intersect, it's right here. So not going to college and female, that is 9 out of the total 52 that were surveyed. Okay, so that's just finding probability from a table. Now what we're going to do is we're going to find conditional probability from a chart or a table. So before I get into how we do it, usually how these questions are structured is it'll say, find the probability of one thing given something else. Okay, so there will be a given in every single problem. What comes right after given? That is your given row. Okay, so this is the condition that's here. So let's look at part E. So it says the probability of going to college given they are female. What this means is we're not looking at the male column whatsoever. Okay, we are only looking at the female column. So this is what I mean by highlight it. You can highlight it with a highlighter if you have one, or you can just make a big circle around the whole thing. Okay, we're not looking at anything else. You can even cross this out. We only are looking at that female column. Now it says, circle the first part of the probability. The first part of the probability is right here. So going to college. So now let's look, going to college is this number right here. So that's what I mean by circle it. Now we can write our probability. So the probability that they're going to college, this is the first part, that's 13. The total now is not 52 like it was before. It's 22 because we reduced our sample space because we're only looking at the females. So that is the probability of someone going to college given that they are female. Okay, so now I'm going to erase this so I can do the other ones as well. So let's look at part F. So it says the probability of male given they are going to college. So our given is they're going to college. So I'm going to circle this. Okay, given they're going to college, the whole thing. We don't care if they're not going to college. We don't care about the total over here. We only care about them going to college. Now the one before that is that they're male. So looking here, this is the part where they're male. So the circled number is 16. And the total here is 29. Remember, we're reducing our sample space because now we're only looking at the people that are going to college. We're not looking at any of the other people. Okay, I'm going to erase it so we could do the last one. Now it says the probability of going to college given, they are male. So we only care about if they're male. We don't care if they're female. We don't care about the total. Only care about this circled column. Now we're looking at the probability that they're going to college. So looking here, this is the number of males going to college. So that is 16 out of our total in this big circle or this highlight is 30. So it is 16 over 30 is the probability. Okay? So conditional probability also has a formula. Okay? Now this line here, we read that as given. So this would read the probability of B given A. And to find it, you have the probability of A and B over the probability of A. Notice the A is the given. That's why it's in the denominator, because it shows the reduced sample space. So I'm going to move on. It's a very important formula. Okay, some notation. Just keep in mind, so this given is always going to be given. There's not another way to write it. And can turn into this upside down U, which is the word for intersect. Okay. All right, let's look at this first problem. It says, of the 650 juniors at Arlington High School, 468 are enrolled in Algebra 2, 292 are enrolled in Physics, and 180 are taking both courses at the same time. If one of the 650 juniors is picked at random, what is the probability they're taking physics if we know? So remember, this is another word for given. If we know that they are already in Algebra 2. So here is our given that they are in Algebra 2. So let's first outline what A and B is going to represent. So A is our given, okay, because remember this is said B given A. So we're given that they're in Algebra 2, so we're going to label A as Algebra 2. B is going to be Physics. Okay, so we have the probability, we need to find the probability of B given A. So Physics given Algebra 2. Okay, this is equal to the probability of A and B. I'm just writing it out for now. A and B over the probability of A. So I'm going to do my work to find those on this side. So first let's find the probability of A and B. So this is the probability that they're taking both courses. Notice there's no given here. It's just A and B. So the probability that they're taking both courses, it says here that 180 students are taking both courses. So the probability of A and B is 180 over the total 650 juniors. Okay, so that's the probability of A and B. Now we have to find the probability of A. So the probability that they're in Algebra 2. If we look here, 468 students are enrolled in Algebra 2. So that means 468 out of the 650 students are in Algebra 2. So now that we have both of these pieces of information, let's plug it back in. So the probability of B given A is equal to, the probability of A and B is 180 over 650. Now we have a fraction. This means, since we're dividing, we're going to be dividing fractions. Whenever we divide fractions, I like using the division symbol because that kind of helps me remember that we need to use keep, change, flip. So I write the two here. This is A and B, this is A. Since we're dividing fractions, we need to use keep, change, flip. So this stays as is, so 180 over 650. The division changes to multiplication, and we flip this last one to give us 650 over 468. And this is equal to the probability of B given A. Okay, so now let's find out what this is. Now you can use your calculator. It will give you the simplest form, or you can use this by hand. The 650s will actually cross out because one is in the denominator and one is in the numerator, but I'm just going to use the calculator to eliminate any type of mistake. Okay. So we have alpha, y equals, we have 180 over 650 times alpha, y equals 650 over 468. And we get 5 over 13. So the probability of B given A is equal to 5 over, what was it, 13? Yeah, 5 over 13. Now, if you want to write a sentence about it, you can say the probability they are taking physics given they're in Algebra 2 is 5 over 13. So that would be a nice little explanation. Moving on. Okay, so let's do another one. It says, historically, a given day at the beginning of March in upstate New York has an 18% chance of snow and a 12% chance of rain. If there is a 4% chance that it will rain and snow on a day, then calculate each of the following. So the first one is the probability that it rains given that it snows. So just remember that the probability formula, so the probability of probability of B given A is equal to the probability of A and B over the probability of A. So the probability of the given goes in the denominator. So here, if we were to convert it to that, we have the probability of rain and snow over the probability of the given, which is snow. Okay, now let's fill in what that is. So probability of rain given snow is equal to the probability of rain and snow. It says that there's a 4% chance it will rain and snow. So it's 4%. We don't like putting percents in our equation, so we're going to change it to 0.04 because we don't like percents when we are dealing with some type of operation. Now we're looking at the percentage of snow, and there's an 18% chance of snow. Again, we don't like putting 18%, so we're going to change it to 0.18. And let's figure out what that is. So rain given snow is equal to 0.04 divided by 0.18, and we get 0.22222222. Since it's not a terminating decimal, change it to a fraction. So 2 over 9. So this is equal to 2 over 9. Now let's look at the second one. So the probability of snow given rain. So I'm just going to write it out. So the probability of rain and snow over the probability of rain, because the second one always goes into the denominator, the given. So probability of snow given rain is equal to, we already found the probability of rain and snow. It told us it was 4%, which we changed to 0.04. And now we're looking at the probability of rain. The probability of rain is 12%, which converts to 0.12. Now let's find out what that is in our calculator. So we have 0.04 divided by 0.12, and that gives us 0.333333. We have to change it to a fraction, and we get 1/3. So 1 over 3. Okay, the last question we're going to do together, it says the set of data below shows the results from a survey. If a person in the survey is selected at random, what is the probability that the person texts over 50 messages per month given, oh, I see that special word there, given that a person is between the ages of 23 and 60. So here is our given, the ages. So 23 and 60 is right over here. We don't care. 15 and 18. We don't care. 19 to 22. Okay? Now, the part before that is that they text over 50 messages. So this is the number where they're texting over 50 messages. There's something different about this problem than the ones we've done before. There is no total columns, okay? So what we're going to have to do is to find the total, we're going to actually have to add up some numbers, okay? So why don't we do that first? Let's add up the total of the given. So we have 25 plus 47 plus 157. So 25 plus 47 plus 157, and we get 229. So 229. Now to write our probability, the total goes on the bottom of the highlighted column, so 229. The circle number goes on top, so 157. 157 over 229 is answer choice 1. Okay, so to get credit for this class, you have to do this check for understanding problem, complete it on a separate piece of paper, show all of your work, and then upload it to the Google Classroom. Have a great day, everybody.